Hi everybody, thank you for coming to this presentation. My name is Thomas Guerin. I'm an Android developer at Xebia France. And today I'm going to talk about Espresso, which is a functional test library for Android. So this presentation is divided into two parts. First, I will make a 10-minute introduction on why I decided to use Espresso. And then I will make 20 minutes live coding with Espresso. So when looking on the web on how to write Android functional tests, it's not rare to find people that say, my tests last hours, or testing is sometimes complicated. Worse, my tests randomly fail. And my favorite, I have to fix all the tests just because I've made a simple modification in my code. So a quick conclusion would be, don't write tests. You're just going to waste time, so not worth to do it. But I still have 29 minutes to spend, so I will change this conclusion to, okay, write tests, but with the right tools. But finally, all these complaints show what a test must be. A test must be simple. By simple, I mean easy to read and easy to write, because it will make your code more maintainable. Then a test must be fast, because you need to have feedbacks as quick as possible in order to have a good idea on your project health. Then the most important point is your test must be reliable, because if you are not confident in your tests are just becoming useless, because the day one of your tests is going to fail, there will be no one to take care about. And finally, a test must be durable. I don't want my test to be broken just because I've moved a button in my hierarchy, or I just added a functionality on a screen. So as a good Android developer, my first try was to go to the Android developer website and read the documentation about the instrumentation API. But when I see this code, I just, whoa, that's not possible. I'm not going to write 10 lines just to check a spinner position. That's not possible. So I started to look around, and I discovered Robotium. So Robotium is an abstraction layer on top of the instrumentation API, and could be considered like Selenium for Android. Robotium has a pretty straightforward API. It's just one class with a lot of utility methods, like click in list, get view, click on view, go back, set navigation drawer, really a lot of methods. Search text also. So writing tests with Robotium is much more easier than with the instrumentation API. So in this example, we are going to click on a button in a first activity that will launch another activity. Then we wait for a certain condition. Often it's only we are going to wait for a view to be visible in the next activity, and then we are going to click on another view. But there is something wrong in this test, is this part. Because Robotium is not going to do synchronization with the application state. So it's your job to write the condition that will make Robotium wait to go on to the next step. So if you misconfigure the timeout, you can easily have tests that are going to fail because your service is going to take more time to respond. So if your timeout is too small, your test will fail just for nothing. And Robotium have some drawbacks. So the first one is Flaky test, because if the timeouts are not well configured, you will have tests that are going to fail randomly. And then it's really hard to extend, because the API is just one class and you cannot add functionality easily. The only proper way to do it is to fork the project and add your functionality and submit a pull request. And the view index-based methods. So if you use Robotium, you must avoid to use this kind of methods because it's too easy to break them. Because if you rely on this kind of methods, just by adding a button on the screen or in the screen, your tests are going to fail because the index of this button has changed. And also, Robotium errors are not really meaningful. When Robotium can't click on a view, it will just tell you, hey, I couldn't click on this view. But you don't have any contextual information that help you to find out what is going wrong. So it's really difficult to debug Robotium test. So you need to add to use other tools to give some contextual information. So that's why I decided to look again for another library. And in October 2013, Google open sourced Espresso, which is also an abstraction of the instrumentation API, but with a really different way of thinking. So, but before going on Espresso, I will remind what is Hamcrest, because Espresso use a lot of Hamcrest functionalities. Hamcrest is just a library of matchers. So with Hamcrest, you can match pretty everything. So for example, you can match a string. So in that case, we assert that the string hello is equal to hello. But you have also syntactic sugar. For example, equal to is equivalent to is. So you have assert that hello is hello. But Hamcrest also provide a lot of matchers. You have, for example, Olaf to match a combination of matchers, not to invert a matcher, instance of, and for example, equal to ignoring case to match a string ignoring its case. But what is really interesting with Hamcrest is it's really easy to compose matchers. So you can build powerful matchers just by doing some composition of simple matchers. That's really interesting. And also, it's really easy to write custom matcher. For example, if you want to create a matcher that checks that a view is visible, you just need to create a static method and return a new type safe matcher. So it's a matcher for view. And you just need to write two methods. The first one is the describe to. It will describe what this matcher is going to do. In our case, it's just going to check that the view is visible. And then you have to override the matches safely, which is to implement the matches safely. And it's here that all the magic happens, because it's here that you're going to check if the view is visible. So let's move on to the API of Espresso. So Espresso have a main class, which is Espresso. And this class has two methods. The onView, to interact with basic view, like text view, button, image view. And to find view, you can use view matchers. View matchers are Hamcrest matchers, but Android specific. So you can find a view with ID, with text, and the funny one is as sibling to find a view next to another one. And then we have the onData. The onData must be used to interact with adapter views. So views that rely on adapter. And why the onData take a matcher of object? It's because Espresso will look in the adapter the position of the requested data, and then we'll scroll the view to this position, and then you will be able to interact with this view. So when calling on view or on data, you're going to create a view interaction or a data interaction. And with this interaction, you have two possibilities. You can do a perform, so you are going to act on a view, to perform an action on a view. For this, you are going to use view actions, like click, type text, or check, to check a certain condition, to check or assert condition on a view. For this, you can use view assertions, like does not exist, or matches that take matcher of views. So with Espresso, we can tell goodbye to flakiness, because for each test application, Espresso will wait until the app is idle, then run on the UI thread the test action, wait until the test action is complete, and then we check the result. So you don't have any wait for in your test. So that's pretty cool. So let's move on to a little demonstration. So I made a simple application. With the first screen is just a login, basic login. You can click on the login, and we are going to load some images. So it's images on landscape images. We have a navigation drawer with some options. So we can click here and load kittens images, and we can go on detail and see the detail of the picture with a long description, and a button that is hidden. You have to scroll the view to see the button. So now we are going to write some tests to test this application. But we are going to begin with the Gradle build file, because Espresso needs a specific instrumentation test runner. So you are going to declare it with test instrumentation runner, and you're going to use the Google instrumentation test runner. And why Espresso uses this specific instrumentation test runner is because it ensures that the application on create is terminated when the instrumentation starts. Then it will ensure also that all activities are finished when the instrumentation exits. It improves the error logging and add other functionalities. So now we are going to the sample tests. And you can see I've overridden the setup method and call the getActivity. We call getActivity here because Espresso will not launch the activity for us. So we need to call getActivity to launch the login activity. So now we are going to click on the login button. So for this, I'm going to use the Espresso on view. So we can see that the on view, and then we can use the view matchers. So with view matchers, I'm going to use the with text, and I'm going to search for the login button. Then I've created a view interaction, so I can call perform, and then I can use a view actions and call click. So if I run this, it takes some time. Oops. It fails. Why? We are going to see what Espresso tells us. And we can see that multiple views correspond to our condition, which is with text. So I'm going to the login activity, and I can check in the console that that's true. I have two buttons here that matches the condition with text login. So going to the login layout, I can see that I have a hidden login button. So I need to find another condition to click on the first button. So instead of using the with text condition, I will use the with ID, because I'm sure that this ID is unique. So only one view will be found when Espresso will look for it. So I call login button. We can do some static import to make the code much more easy to read. And with only 2 methods, we can click on the button. So now everything should be OK. And the test passes. So now we are going to be on the grid view activity. So where all the images are. There is a little information that is very important to know is the data is loaded with Nissan task. It will be. I will explain later why. So for the grid view, I'm going to use the on data. And I'm going to show you my pictures adapter. And my pictures adapter return a picture model. And the picture model is only a simple object with a title and a drawable resource. So in my sample test, I will say I want data that is an instance of pictures .class, and then I will perform and at position 4, I will perform a click. So I run this test. Everything should work. And that fails again. Why? Because in this view, I have 2 adapter views. I have this one for the images, and also this one. So Espresso doesn't know on which adapter view it has to act. So I will use a specific method, which is in adapter view, and tell Espresso it has to click in the picture grid view. And now the test should work. And the test passes. But I don't like this kind of test action because at position 4 is not meaningful. I don't know what is in this position 4. So I will write a custom matcher to find a specific title. So for this, I will write a method with picture title. Oops. Picture title. That takes a string matcher as parameter. So it will be equal to, prefer is, landscape 1. Oops. And what's wrong? So I will create, I should remove this too. Oops. So I will create this custom matcher. I declare this method static. And I will return not a type-safe matcher, but a bounded matcher. Why a bounded matcher? Because I want to return a matcher of objects, but I want this matcher to only apply on picture. So I will declare the first type parameter as object, and the second one as picture. So I will return a matcher of object that only applies on picture. It needs the picture.class as parameter for the constructor. And then we just have to override these 2 methods. So the first one is the describe, really simple to write. It just append text. And I want to say for picture title. And then I can append a description and just give the description of the string matcher. And then the matches safely is pretty straightforward. It's just string matcher matches the picture title. But so now we are going to find the picture with the title landscape one. And when we find this picture, we can interact with child view of the grid view. So we can call on child view with text. So it should be text and landscape one. Oops. We can check, for example, that is displayed. So is displayed will guarantee that 90% of the view is displayed on screen. If you want 100% to be displayed, you need to call is completely displayed. So now we can run the test and everything should work. And the test passes. Okay, so let's move on, and we're now in the detail activity. So in this activity, I want to scroll the view and click on the scroll on the button. So for this, I will call the onView with id air.id.scroll to me, and then I will perform. I can do, for example, a check. I will check that the view is not displayed. Because you need to scroll to click on the button, so the button is not displayed. And then you can perform a scroll to scroll to the button, and then click on it. And if I run this, we should see a toast. So now we are on the detail activity. I want to come back to the grid view. So I just call Espresso press back. It will act as a user press back on his phone. And then I want to open the navigation drawer to change the type of pictures. So I will call Espresso open drawer. No, it's in drawer actions. Drawer actions is available in the support v4 of Espresso. So you can call drawer actions, open drawer, and give the ID of the drawer you want to open. And then, as the drawer is open, you can click on the kitten's text. So you can do onView with text. I don't remember, so I will do ignoring case. Kittens. Up. And I do a click. And here I can use the on data, and instead of landscape 1, it should be kitten. For example, 3. I launch the test. We need to wait for Gradle. And the test passes. Oops, not. Why? Why it can't find picture title is kitten 3. Oops. No, it's a good one. It's a picture grid view. it should work. Oh, it's kittens with a S. And that works. So now you can notice that there is no wait for. For example, between the on data and the on view in the detail activity, there is no wait for. Why? Because in the on data, Espresso will do the test action and wait that the application is idle. And as I used in nesting task to load the data, you have to know that you need to know that Espresso will watch the async task thread pool. So it is aware when an async task is running, and it will wait that all the async tasks are finished before going on. So that's why it waits that the data are loaded before going on to the detail activity. So now, if I switch from async task to retrofit, and I launch my test, it should fail. Because retrofit use its own thread pool, and Espresso is not aware of this one. So you need to register this thread pool to Espresso, and Espresso will be able to look at it. But you can't register the thread pool as is. You need to implement the idling resource. So I just write some helper in my test utils. So I will write a custom thread pool that I will give to the retrofit builder, and it will this Espresso thread pool will implement the idling resource. So when implementing idling resource, you will have to write 3 methods. The first one is getName, so you can give the name you want. A method that tells if the thread pool is idle now. It's pretty easy. I use the thread count. So if thread count is equal to 0, this thread pool is idle. And Espresso will register a resource callback. So you need to keep a reference to this resource callback. And when the thread pool is going to be idle, you need to notify the resource callback that the thread pool is going to be idle. So Espresso will be aware that the thread pool is going to be idle, and he will check and see that the thread pool is idle. So now we need to register the thread pool to Espresso, and we are going to use the I don't have much time, so I'll do a dirty thing. So I just use Espresso register idling resource and use my test utils dot Espresso set pool. So I register this thread pool to Espresso, and Espresso will start watching it. And I just override my pictures API in my application. So now, if I run the test, oops. It works. So to conclude, you can see that it's really easy to write tests with Espresso, but Espresso is not perfect. For example, Espresso has no support to web views, and there are still some nasty bugs. for example, especially in the Google instrumentation test runner. So it's sometimes you need to sometimes to fork the Espresso project and use the patch available on the Google Code resource to be able to do a clean test. But everything things should be better in the few weeks, because during the DRECON UK, the Google team announced the support test library. So everything should be okay with this library, and a new version of Espresso will be available. So if you have any question, I will be pleased to answer them. Thank you.